Thanks for coming down and finding your way all the way to the basement for this talk. My name's Lorna. I'm a developer advocate with IBM. IBM are also sponsoring today, so it would be polite if you popped in and saw what they were doing. Last seen building a robot and asking me which way around the LED went, so if everyone could check on them, that would be great. So most of the time I am an advocate worrying about, spreading the good word about the databases that we use. They're all open source offerings, so it's not exactly hardship to get paid to play with this tech and share it. I've also this year been really enjoying working with some of the serverless tech, both on Amazon Lambda and the OpenWhisk version that we have on the Bluemix platform. And advocates don't have a reputation really for writing a lot of code, but I do build a bunch of the internal that my team uses. So in contrast with many of the talks that I give, this one is a true story. So my team and I built this. It's a Stack Overflow dashboard. And what we're doing there is we're tracking certain tags on Stack Overflow where if somebody has a question about any of our technology, and it's quite a big list of tags that we use, then we want to know they've asked the question, and we want to put it here on our dashboard. But we also want to add some metadata. So we need to keep track of if one of us is already looking at it. We're 20 people distributed globally. We're all in different time zones. It's really common for more than one person to try and answer the question at the same time. Like adding any notes if we've put in inquiries with other teams or if we've made a suggestion and the user's trying something. So this is something that as an advocacy team we make enormous use of. And because I need to add some metadata, we bring in the data from Stack Overflow and we store a copy of it in our own database and we attach things to it. So today I am focusing mostly on the bringing things in section. So I've got Stack Overflow, we're bringing in the data, storing it in our database, and that database powers the website that you've just seen a screenshot of. It powers a Hubert Bot that does Slack notifications. There's a bunch of bits and bobs going on there. So today's talk is about the grey dotted line on this very artistic diagram. And we built this with a serverless architecture. Why did we do that? Actually, I thought it was a bit of a misguided idea at first, but I'm a total convert, so I'm just going to say like, oh yeah, I totally had this great idea and it worked really well. I did not have a great idea, but I'm happy that we did it this way. Because it's a cron job, so most of the time this system does nothing. And one of the nicest things about serverless technology is you only pay for it when it's running. So for the 4 minutes and 58 seconds before the next cron runs, we're not paying for that platform. We're just paying for it while it's actually doing something. The problem is you could very quickly draw a flow diagram of how this works in terms of making an API call, getting a list of questions from Stack Overflow, for reaching over the list of questions and doing a thing with each thing. You could immediately draw a diagram of this. It's a relatively small application. I'm not going to create some kind of horrific architecture mess by trying to build this made of many small components. And that makes it a great first serverless project, which it was for our team. Sometimes the serverless functions, so you're going to write a function, you're going to ship it to the cloud, you're not going to worry about ops. It's not no ops. It's really excellent ops, just done by somebody else. So there aren't any ops. There are a large number of really good ops, actually, but you don't have to do the ops. You just write the function and then don't worry about it. Serverless is happening now because of the advances in things like platforms. Without containers, without the ability to clone and quickly spin up many small containers, there could not be serverless. Serverless is absolutely the future and it's catching fire, but it's catching fire now because it couldn't have come before. It's a natural progression in what's happening in the wider DevOps sphere. The serverless functions occasionally can have what we call a cold start time, so the container just gets swapped out if it hasn't been used for a while. So, but I don't care, because it's just like a background batch processing job, and if my Slack notification comes in a whole second later, than it would otherwise have done. That's not a problem. So again, serverless is a great fit for this. Can be a little bit exciting if you're doing it and the user is waiting for a response, but for this, perfect, and I've really enjoyed working with it. I want to say one thing about the database element of this project. It's a document database. I'm using CouchDB. On the Bluemix platform, it has branding codename Cloudant. It's CouchDB. So it's a really excellent document database. Document databases are a way of storing schemaless data. So each record, rather than being a row with a prescribed set of columns, each record can look different to each other record. Spoiler, they mostly look pretty similar because you're going to evaluate all these data records with the same piece of code, so it sounds like chaos, and it usually isn't. It's usually, the records are quite similar, usually just sparsely populated, lots of fields missing, only the ones that we want are in there. If nobody's looking at this, there's nobody assigned to it, the field just isn't there. So that's document databases. CouchDB specifically is one of my favorite NoSQL document databases. Its acronym stands for Cluster of Unreliable Commodity Hardware, which gives you a clue that it's pretty robust and it's kind of pragmatic about the fact that something goes wrong. So CouchDB is intended to be rock solid in the face of all sorts of undesirable occurrences. You talk to it with HTTP, so you can just curl to it, which means you're never waiting for drivers, versions or any of that. Your programming language hopefully knows how to make HTTP calls, so you're not dependent on anything else to talk to this database. It uses JSON and it has brilliant replication abilities. Hold that thought because it will become important later. All right, so let's talk about actually creating a serverless application of your own. I'm showing you around mine, but what I'm trying to do is show you that it's something that I found very approachable. I hope you will too. And I want you to kind of see what's around, what's available. So there's a choice of platforms. Amazon Lambda is at the top of the list. I might work for IBM, but Amazon deserve a mention here. They were trailblazers in this space. Amazon Lambda was out. If you've established, you've probably started here. If you're already in the Amazon ecosystem, I would certainly recommend that you have a look at Amazon Lambda. Also, you'll already understand how to do that I am thing that I always need help with. I am using IBM Cloud Functions, which is the product name for an open source product called OpenWhisk. And the nice thing about having something which is open, but there's a hosted version, is I just develop locally using the open source version, and the whole lot also works on the hosted cloud version, where IBM kindly pay my hosting bills. So I do really enjoy that. Some other options that you might know here, we're at Twilio's conference, so I'll mention Twilio functions, and the next talk is specifically about Twilio functions. So the fact that I've only really done Hello World with Twilio functions doesn't matter, because you will be enlightened a bit more about that. Also, the other clouds have competing offerings. So there's Azure Functions, Google Cloud Functions. If you're not already affiliated with a cloud platform, there are standalone ones. Iron Functions is pretty good. By the same people that do IronMQ, it's a really nice standalone option. This is not an exhaustive list, and if I had written this exhaustive list last week, it would be wrong because there's new players in this space all the time. Genuinely, this is an active and interesting area of technology. Now, I don't know what programming languages you all speak, but my examples today are in JavaScript. They're hopefully not too complicated. Here's the first one, and I'm confident you can all at least read this. So I'm declaring a function. It accepts some arguments. These might be things that I set up when I configured and deployed this function, or they might be things that arrived when the function was invoked. When it ran, it had some incoming arguments, either from an incoming web request or something else ran this function and passed in some extra data. And all it does here is it returns an object. All of the different serverless platforms are slightly different. There's something called the serverless framework to make your code deployable to multiple platforms. So if you're not sure where you're going to deploy to, you don't want to be locked in, you want to use an open source project for development, or you want to deploy to more than one cloud platform for redundancy, there are options to help you. This is for OpenWhisk. For OpenWhisk, you will always return an object like this, or if you have any async calls you're writing to the file system, to a cache, to a data store, I call, you will return a promise. The event loop doesn't keep running after you've returned, so make sure you do return a promise. I'm probably saying some words that you're previously familiar with, so let me attempt to define myself. Vocabulary. We say a trigger, meaning something that happens that causes probably an action to run. So a trigger in my example is just an alarm. It's a cron that triggers the one in the example triggers every 5 minutes. It could be an incoming HTTP request. If you're in integration with Twilio, perhaps it's an incoming text message, right? It could be a database change. I work with CouchDB. You can get a feed of all the changes happening on your database and respond to them. Once you've got your trigger, you need to wire it up to something. And we use a rule to say, when this happens, do this. And the rule is what maps one thing onto another. When I say action, I mean function. This is very important. You cannot have buzzwords and hype if you use vocabulary with which people are already familiar. So we can't just call it a function. People might think they understand it. So it's called an action, but now you're in the know. It's a function. But it's a way of grouping actions together. You can also attach parameters to packages, so you can set an API key that more than one of your actions uses, for example. We also have sequences, and they're not an advanced concept at all. Why was I going to say that? It's something that we, again, don't see on every platform, but it's in this project, so it's important that you understand it. A sequence is where we create something which is a predefined chain of actions, where the output of one action becomes the input of the next. And there might be sort of centrally provided actions where you can put those in between a bit of your own code, or it might be all your own code. So now you're all terribly enlightened and enthusiastic and ready to start. Let me try and show you some of the mechanics of how this works. You're going to write some JavaScript. You've seen index.js already. I am going to zip it and call it hello.zip. You don't need to zip the file when you're working with just index.js, but I'm hoping that you are all going to go beyond hello world. And once you have more than one file, any dependencies that are not already on the platform, or you need to ship config with your function, then you'll need to zip it. So grown-ups are going to zip their code. Here we are. So we zip the code, and then we do whisk action update, the create or update the action. It's zipped, so OpenWhisk can't guess what it is. So we need to say, it's JavaScript. Give it a name. This has got the package name, demo, in, as well as the action name, hello1. Specify the zip file. To run it, you just do this. You need the -- blocking, or it'll just run it and return to you. -- blocking, it'll actually return you the response as well. It'll wait until there's something to show you. Let's just run it. It does exactly what you asked it to do. -- blocking will give you a bunch of data back, including the response. Helpful. One really neat trick, and this is specific to OpenWhisk, all of the serverless platforms have some sort of API gateway where you can map URLs onto actions and set up lots of verbs and things. OpenWhisk has a shortcut, which is that you can just web enable it with this -- web true, and then you can hit it with curl on a URL like this. So deploy it, call it with the action invoke, or web enable it and you can get the URL and then call it. The .json on the end dictates the format. Okay, that was your serverless primer. Let's have a look at the project itself. So I'm bringing data in from Stack Overflow, working out what we've got. Have we seen this before? Do I need to update a record? Do I need to notify that we've got new questions? So one thing I want to mention about this, we built this app in an offline first kind of a way. And that means that I can always work on this I'm not often in a place that really doesn't have any connection. We have like hills and tunnels and things on our train. It's very inconvenient. Maybe we should try and eliminate those, but means that my data connection is often really spotty when I'm working on the train. So offline first, we have a completely client-side application and some client-side storage. In this case, it's something called CouchDB. It's a JavaScript implementation that can talk CouchDB replication protocol back to my real database, which is clouded on the server. So I have CouchDB, client-side JavaScript, and a database all in the browser. In the event that I am connected, even temporarily, whatever's changed on either side gets synced across. So the really good replication protocol becomes very, very valuable at that point. So we are building in this way. I don't think it's a huge impact on how you understand things, but I just wanted to be clear about what's happening here. So what we're aiming for, lots of small components. Anything you've heard with microservices in the title, apply that knowledge now. Thinking about building very discrete, independent pieces and wiring them together, passing data in a sane way from one to another, trying not to create either very large actions or a lot of kind of tangle. So observe data hygiene, thinking about each component accessing one data store, but not having lots and lots of functions that all talk to the same database. Saw a database administrator recently, and I said, how's it going? He said, oh, it's terrible. They're implementing microservices. The load on the database is like 10 times what it was, because every microservice then fetches the same information from the database. Do not do this. That's an HTTP-enabled monolith. It's not what you're aiming for. All right, so mine looks like this. The clock is the cron job. So every 5 minutes, the alarm goes off, and we run the collector action. And the collector goes to the Stack Overflow API, runs whichever search we're running, and gets a big array back. It's a big JSON array with questions in it. And all it does is pass it through to the invoker. And the invoker looks at each question, and for each of the questions, it programmatically runs another action and injects the question to each one. So from the invoker, we spin out a whole load of simultaneous serverless function calls, each getting their own Stack Overflow question data object in it. So this is, serverless will just scale up for you. It's there when you need it. You're not paying for it when you're not using it. So from the invoker, we get many more actions. So there's a lot of copies of Storer. And Storer says, have I got this already? Do I already know about this question? No. Save it. Do I already know about this question? Yes. OK, well, let's update it in case anything's changed. Finally, the notifier gets information about whether this was a new question, so whether we had to insert or update. And if it's new, it lets the channel know. So I have a bot that gives me a nice formatted Slack message with, do you want to see this on Stack Overflow? This is what's happening, little excerpt, the tags that were associated with it. So one sequence called Stack Overflow cron, SO cron, has the collector and the invoker, and then the invoker fires off many of a second sequence, which does the storing, and the storer output passes on to the notifier. Now, hold on to your hats. I want to show you around. The code more or less fits on the slides, with a few omissions and a little bit of white space crime. It's also all on GitHub, so if you want to see it in context, you can. But this is not a million miles from how this really works. So, first of all, we set up those triggers and rules. So we delete the existing trigger, create a new trigger, and say, I want you to fire the built-in alarm thing, that's the cron job, every 5 minutes with the following data. And it's just some tags that I'm searching for. And then I have the rule that links it to that SO cron sequence. That's all that does. Here's the collector. We use the request module in JavaScript. I've got a main function. And all this does is it returns a promise. It looks at the tags that came in, so it's what the rule tags sent in, and looks at those tags, builds the search URL, makes a web request, and on the response then, it errors if things have gone wrong, but hopefully it successfully resolves the promise and passes in the big list of items that we got. Because that's what we're aiming for. This is almost verbatim, the code here. You can all read this even if your programmers are other languages. Serverless is made of small components. It's really achievable. Here's the invoker. This is a little bit special because it itself calls a bunch more actions because we need to spray them out into a sort of a distributed processing so we can process these things all in parallel instead of trying to loop over and not knowing where we got to if something went wrong. For this, we use the OpenWhisk library from NPM, and we just we create this array of actions. So for each of the items that came in from the data set from the previous action, for each of those actions we attach, for each of those items, we run a map which we attach a function. So we get this array of actions which has a function, and then we just promisify the lot and resolve with those. And that's the end of that sequence because it has sort of delegated and started a bunch more sequences. We've run the queue handler, the question handler for each individual question. There's only 4 of these. Here we go. Here's the storer, and all this does is, because the Stack Overflow question ID from the URL is unique, we use it as the identifier in the CouchDB database. So do we have this ID? Yes or no? If we don't have it, then insert it. The update looks more or less the same, so I just chopped it straight out my slide. Again, we're returning the promise here because, which is what getDoc does, because it's a database call. So it's asynchronous in Node.js. And finally, we notify. We just check on line 4 if the data has a status new set. And if it is, we should do something about that. And we send a webhook out. So we just send the whole data, status new, and we send the webhook to the hard-coded Hubert Bot URL. This is a very actively developed project. I did remove the actual variable hard-coded Hubert Bot URL, but that is what it's called. It's probably hard-coded in the GitHub repo as well. Please let's send webhooks to my Hubert. And then it lets us know what the outcome was. So, you've just seen all of the code from quite a complicated serverless data pipeline. Whether you're writing this in, these examples were Node.js, but there's no reason that you shouldn't be using Java or Python or Swift or Go or PHP. They're all supported by all the various platforms. Different platforms support different ones, but they all support Docker containers, so you can just package up your function and ship it. This is something that we can all do. I mentioned Hubert. Hubert's cool, so it's going to get a mention in my talk. We use Hubert to hang out in our Slack channel. I've used it a lot with IRC as well. It's a GitHub project originally, although it's now under more general open source care. And the idea here is that this bot is a presence in your channel. It can respond if you talk to it. It can overhear you saying things. It can respond to an external stimulus, such as my webhook, and put messages into channel. For Slack, it also understands reactions. Anyone got any new product development ideas when I say that? Ours will respond to reactions. So when the questions come into channel, people will be able to say, we don't need to answer that, or I'll take that one with a reaction, and it'll pick that up. Haven't built it yet, might be next year's conference talk if they let me back. But have a look at this. It's got lots and lots of plugins, so most of the time what you need is already there. And it will also integrate with Campfire and HipChat and whatever other cool things the kids are using these days. So one of my favorite projects. What I've tried to show you here is a very specific case study. It's made of serverless building blocks. It moves data around. There's 2 really important points that I want to make off the back of this, and perhaps as a result of reflecting on what I've built. Serverless is not the future, it's the present. I'm seeing it implemented in all sorts of places and in all kinds of industries. If you have a problem which you just need to farm the work off your web server, if it's helpful to be able to madly parallelize for a short period of time, maybe it's a batch import, Maybe it's a bunch of thumbnail resizing. There's a lot of really good use cases, and the technology is available now. It's ready now. And I think you are at the leading edge of implementing ideas like this. It lends itself well. I already mentioned it happens because of the evolutions in platform tech, but also evolutions in the way that we think about architecture, the way that we think about building our applications. Thinking about microservices and wanting to make small reusable components that scale well, that can be independently managed and deployed. The tooling is perhaps at an early stage for some of these platforms, but it's changing all the time, and all the time for the better. The other point is what a good fit serverless tech is when you're working with data. For a long time, we've handled big data mostly with distributable, map-produced jobs. This feels a lot like this, breaking the workload up into many small pieces and running it on as much compute as we have available. Realistically, all the platforms do have caps, so you and if you're not careful with this, it's very easy to run up some very big bills, but all of the serverless platforms have free tiers, tens of thousands of free invocations. You can play with this and run some pretty serious small-scale applications without paying anything at all on these serverless platforms. If you're working with distributed systems, scalable systems, occasionally bursty traffic systems, I did one which was smart energy, and they used to wire up millions of sensors into a block of flats and then literally turn it on. The whole lot would phone home at once. That kind of use case, absolutely ideal. So moving data around, handling data, converting data, I think there's a lot of applications here. So I am going to be here all day. I'll probably be hanging out mostly at the IBM booth, so go and talk to them. I'll be there in the lunch break. I am fascinated to hear what you're doing with serverless, what you think you might be doing with serverless, especially with data, but also any questions that you have about it. I'm implementing this stuff, but I'm an advocate, so I get to write tutorials and build sample apps. What's interesting to you? What do you wish there was a tutorial for? I would be the right person to tell about that. So yeah, finally, here's some resources for you. I've also tweeted this slide. So if you want this, about half an hour ago, I pre-scheduled all my tweets. So they're like, I'm on in a few minutes. Here's a link to my slides. Tweet went out easily half an hour before I started talking. And the resources slide went out just as I kind of stepped up. So you might need to scroll back through the conference noise. But some stuff here that I've tried to link to everything that I've used, and specifically the GitHub code, if you want to dig around on that. I am making no promises about how reliable that is for other people to use, but you're very welcome to try. And with that, I'll just say thanks for your attention.
Thank you.